Hi friends, I think you liked my previous videos. Today we are going to learn a topic of physics, is first and second law of motion. We all know about motion. So there are three laws of motion. So let us start. You know this? It is Isaac Newton. Isaac Newton, he has introduced three laws of motion. The third law is very complicated. So next video we can learn that. So in this video we will learn about the first and second laws of motion. This is stated by Newton. You know this person? He is Galileo Galilei. He discovered the Saturn, Jupiter, Uranus, Neptune, the four outer planets, and also he discovered the first telescope. And he was killed for the reason that he said that not the sun revolves around the earth, but the earth revolves around the sun. So according to the study based on Galileo Galilei's experiment of this ball and inclined plane, Newton made the first law of motion. So he studied this experiment of Galileo Galilei and then he made the law, first law. So in this it is what is happening. A particular height is there and this is an inclined plane. Inclined plane, you know, a plane with a certain height, inclined at a certain height, having an angle with the surface. So a ball is kept here and it is made to drop and it is rolling. So this ball will try to obtain the same height. Suppose this height is h. So this height, the ball to the surface, this is also h. So the ball will try to gain the same height again. So it will roll until it will reach the same height. So inclined plane, if a ball is rolled through an inclined plane, it will try to get the same height and the distance may be increased, but it has to gain the same height. Now here, this is the same height. This h and this h is same, but here it is increased. H is increased. This is the increase symbol. So h is increased. That means height is increased. So as the height is increased, the ball is covering more distance to reach the same height. Angle is less. It is less. Or we can say angle is less. So not the height increased, it is height decreased. Now the third type of experiment is that here a certain angle is there. Suppose angle theta. Suppose angle theta. And but here you can see there is no angle. That means what? It is 0 degree angle. The surface and the inclined plane matches. So it can never reach the same height. This ball will roll forever because it will never reach the same height because it is 0 degree. It can never reach this height. In this, if the angle is made less, then it can cover a large distance and get that height. But in this case, it can never get the height because it is 0 degree. Where how much distance it may cover, so no height means same height it will never get. So this was the experiment based on this first law of motion was made. Newton's first law of motion. Until and unless an external force is applied on an object, the object continues its state of rest or of motion in uniform velocity. Now, what is the motion in uniform velocity? That means on a straight line. A body will move in a straight line with the same velocity, no change in velocity. That means no acceleration. So until and unless an external force is applied. Suppose a ball is kept at rest, a ball is at rest, you are pushing the ball, so the ball will roll, and if you are not pushing the ball it will remain there, so it is continuing state of rest. And a car is moving on a straight line, on a straight path, it is moving with uniform velocity. So what will happen if you pull brakes, then the object will be at rest. If you apply brake, then object will be at rest. Or you can increase the acceleration, but the object itself will not change its state of motion. It will be in motion. If no force is coming in the obstacle, as the obstacle no force is there, so F is equal to 0, then no force, that means an object will keep it state of rest or of motion in uniform velocity. It's very simple. Based on this, we'll learn something else. Inertia. Now, the concept of inertia. What is inertia? Inertia is the tendency of an object to resist a change in its state of motion or of rest. So it is almost same as the Newton's first law of motion, the law of inertia and the first law of motion. How is it same? That says that if no external force is there, then the state of motion will be continuous. State of motion or rest will be continuous. It also says that state of motion and rest will be always continuous. So if there is no external force, then the both the laws are same. Okay. So, and also mass is a measure of inertia. Mass is the measure of inertia. To exemplate, let me tell you, a football you are kicking. If you kick a football, the mass is less, okay, and if you kick a stone, the mass is more. So football you can kick easily, but stone you cannot kick easily. It will, if you can also, a little distance it will go, but football can be kicked at high heights and distances. So that means more the mass, more the inertia. What is happening? Why the stone is not moving? Because it has more mass. So as more mass means more inertia, so it is trying to continue its state of rest. The stone is not moving and trying to continue its state of rest. But football is as less mass, it also tries to resist a change in its state of rest. But due to its light mass, it moves a bit distance. And one thing I forgot to tell you, in the Galileo's experiment we saw this inclined plane. Suppose this is inclined plane, so a ball is rolled and it will reach this height, right? But this surface has to be frictionless, it has to be smooth, completely smooth surface, because when it will move in the zero when the angle will be something theta, and this will be 0 degree. So what will happen? This, if this will be 0 degree, if this thing will be 0 degree and this will be theta, so it will continue to move on its path only when the surface is a frictionless, because friction is an opposing force, we know that, and friction will stop the ball, then it cannot continue its state of rest. Okay. It cannot continue its state of motion. Okay, it will come to rest. But there is no surface possible that it is totally frictionless. It may be less friction. Many lubricants can be applied, or many other new techniques are there which can be applied for making less friction, but it cannot be frictionless. There is no surface. Even microscopic view, if you see, there is friction. If through your eyes you cannot see the friction, if you cannot see the grooves and ridges, then through the microscopic view you can easily see the grooves and ridges between the two surfaces where friction is occurring. So it has to be frictionless, then only it will move, otherwise friction will stop. But to assume the law, to prove the law, we have taken that it is a frictionless. Now there are three types of inertia: inertia of rest, inertia of motion, inertia of direction. I will explain you this three with the help of the example of car. When you suddenly start a car, when you suddenly start a car means it is at rest, the car is at rest, and you suddenly accelerate, you press the accelerator, and what will happen? If you will notice that you will move back, you will hit behind the seat, and means at a high speed, at a high change in velocity, if you start from 0 to high velocity, that means only you will get back. Why? Because of the inertia of rest. The car is at rest, so it will try to continue its state of rest. So that's why it is pushing you back, so that you are in contact with the seat of the car to be in rest with the respect of car. Now inertia of motion: when suddenly brakes are applied, when a car is in motion and suddenly brakes are applied, you move to the forward direction. Why this happens? Your below part, your down part of the of your body is attached to the seat. You're sitting on a seat of the car and it is attached to the seat, so it will come to the rest with the seat, with the car. But your upper part of the body, which is in uh, in motion of the car, which is in respect of the motion of the car, so it is moving with the car. So when it will stop suddenly, then what will happen? It will try to resist a change in its motion and it will try to continue its motion. As a result, it will move front. Okay, so inertia of direction: suppose a path like this is there, so you can notice here that there are curves. So if a car is moving like this, it is going, so when it will take a turn, suppose it is here, it is taking a turn, so while the turn, you will be shifted to the right side, you will be shifted to the side the turn is taking. Suppose a turn is like this, so suppose you are moving like this, you will be moved to this side, you will be just the opposite, you will be like this. So when the car will move, you will try to keep your direction also constant, because speed and direction is the state of motion, and direction are very important differentiation points of or distinct points of inertia. So you will move to the side of the car which the turn is twisted to, not this side, not the cut side, but the overt side, the rounded side, not the cut side. It is the rounded side you will be shifted to. Whether it is here, then this side you will be shifted, and this is the cut side. So rounded side you will be shifted to. This is the inertia of direction. Now we'll start second law of motion. Before starting second law of motion, I want to introduce about momentum. Now momentum is a very easy topic. It is a physical quantity. Momentum is a physical quantity which depicts mass into velocity. Mass into velocity, it is the product of mass and velocity. Momentum is always constant and it is the product of mass and velocity. M stands for mass, V stands for velocity, and momentum is depicted by P. And the unit of momentum in SI unit. Mass, what is the unit of momentum? Sorry, let me change the color of the pen. kg, right? Mass is kg. Dot means, I think you understand, dot means into. So mass into volume, sorry, mass into velocity. So mass is kg and velocity in SI unit is m by s, meter per second. It is also the same. This is the unit of momentum, kg into meter per second, SI unit of momentum. And if you change in CGS, it will be g into cm by s. This is the this is the CGS unit of momentum. So what is second law of motion? The rate of change of momentum. So momentum means change in momentum, that means P1 minus P2, and P means mv. So the change in the product of mass and velocity, the change in momentum. So P1 by P2, P2 minus P1, okay, P2 minus P1 by T. Rate of change of momentum means only the change of momentum by time. So this is 1. P2 minus P1 by T. So we will prove it. Do not get confused. So the rate of change of momentum is directly proportional to the force applied on it. So the force applied on it is directly proportional. This is the symbol of directly proportional. So this means what? The rate of change of momentum is directly proportional to the force applied on it. It means a body is moving, so it is changing the momentum. The velocity is changing as well as the momentum is changing. So the rate of change of momentum which is occurring is directly proportional to the force applied, the force due to which the change is occurring. A mathematical proof of this second law of motion. So let us consider an object of mass m moving on a straight line with an initial velocity u and final velocity v. This is a statement, nothing else. Mass is there, which is m, and initial velocity is u, final velocity is v. So p is equal to mv. We know this. What is p is equal to mv means? Momentum is equal to mass into velocity. So initial momentum means mass into initial velocity. Mass will be constant. Mass is same thing. A body has a single mass. It cannot have two more masses unless you add something or decrease something. So initial momentum is equal to mu. So for initial momentum means only initial velocity. So mu, u is the initial velocity, so m into u, and I'm sorry, it will be final. It will be final. So it is final. Initial momentum and final momentum. It is not initial, it is final. Final momentum is equal to mv. So v is the final velocity, so m into v. So change in momentum is equal to mv minus mu. Change in momentum means final momentum minus initial momentum. So mv minus mu. If you take m common, then v minus u will be left. So rate of change of momentum, what I said, at p2 minus p1, this let it is p2. This is p1. What I said, p2 minus p1 by t. So we have taken already common, so m into v minus u by t. Second law of motion states what? Directly proportional sign will be there here. Says what? F is directly proportional. This is the symbol of directly proportional, like alpha. So F is directly proportional to m into v minus u by t. It says that the force applied on a body is directly proportional to the change in rate of change in momentum. So m Rate of change of momentum is m into v minus u by t. So k is a constant of proportionality. Here is we have said that k is a constant, where k is a constant of proportionality. Means as the force will increase, the rate of change of momentum will also increase. So for that we are putting a constant of proportionality, that is k. So k into F is equal to remove the proportionality symbol and put the equality sign. So F is equal to km into v minus u by t. V minus u by t means a, acceleration. Acceleration is equal to change in velocity by time. Rate of change of velocity is only called acceleration. So F is equal to kma we have got. Now if m is equal to 1 kg, what is the definition of 1 Newton force? 1 Newton force is the force applied on a mass 1 kg, mass of 1 kg with an acceleration of 1 meter per second square. I repeat, 1 Newton force is a force which is applied on a mass of 1 kilogram with acceleration of 1 by 1 meter per second square. So if mass is 1 kg and a acceleration is 1 by 1 into m by second square, that means s square is the exponent symbol. It will be like this, right? S square, that means second square. So then the force will be called 1 Newton. 1 Newton force is equal to k into 1 kg into 1 meter per second square. Okay, any value. So 1 Newton, we said that 1 kilogram into 1 meter per second square. Now any constant we can put here, for example, and if 1 here it is, so this side also will be 1. So 1 into 1, so left 1 will be also 1, so k is equal to 1. So if k is equal to 1, then F is equal to 1 into m into a. Dot means, I said, into, dot means into, same thing. Multiplication symbol, dot. In higher classes you will get this. So F is equal to 1 into m into a. So F is equal to ma. Very easy proof. You can see later on. Okay, now examplating some topics. Based on second law of motion, we are getting something. We know that, okay, let me say the question at first. Here you can see that when you have noticed also, I think, while playing cricket, if you are a fielder, if you in the fielding team, so if when you are going to catch a ball, catch out, then if you raise your hands and catch the try to catch the ball, then your palms are hurted sometimes. Your hand is paining when you catch the ball. Your palms hurt. Why that is happening? And that's why you will see that the good fielders, what they do, they bring their hand below. They bring their hand below like this. They're bringing it below to catch the ball. Not at a upper rate. Before catching the ball only, they are putting their hands like this here. Here they are putting their, in this position. They are putting their hands to catch the ball. Not up. They are putting it down. Why? In this case, the time to reach the ball to the hand is very less. T is less. So, if rate of change of momentum is directly proportional to force, okay. So, here the if the time is less, then the momentum will be more, the rate of change of momentum will be more. Rate of change of momentum, that means mv minus mu, right? In short, in mv minus mu, that means the final momentum minus initial momentum will be increased. Why? Because mv minus mu by t, so it is by t, so t if it is transposed, then it will become into, so it will be inversely proportional. So time is inversely proportional to the rate of the time is inversely proportional to change in momentum. So as the momentum will be more, we know the rate of change of momentum will be more. We know that the force is directly proportional to rate of change of momentum, so force will also increase. So as a result, more force will be acting, so our hurt means the our palms will be hurted. Force will increase. Now let us see in this case what happens when the ball or the hand is put down and then the ball is catched. What happens? So time is increased or not? Time is increased. Why? Because when the at this distance when you are catching the ball, it is time more, means time less it is taking to reach your hands, and here the time is taking more. So as a result, p1 minus p2, sorry, p2 minus p1, change in momentum will be less. As a result, force will also be less. So which is more beneficial? This one is more beneficial. One more exemplate we have here. Let us see. You must wear your seat belt. Seat belt wearing is very important. This has also a relation with the second law of motion. How? Let us see. When you are not wearing seat belt, what is happening? If an accident is taking place, you suddenly apply brake. You suddenly apply brake. So what is happening? The change in velocity, that means the change in momentum, is occurring in a very less time. So t is less. Change in velocity, what is happening? Very fast, na? From high speed you are going and suddenly you have to press the brake. So what happens? You are shaken and you pull forward. You have to pull forward, but it is a rule by the first law of motion, the inertia law. We understood that if you suddenly apply brakes, what happens? Inertia of motion acts, which helps you to resist a change in your state of motion. So you fall forward. But we have to fall forward, but we can reduce the chance of accident. How? So time taken, if you not wear the seat belt, so change of velocity is always time taken is less. So suddenly you are applying brake, so change in momentum p2 minus p1, p2 minus p1 will be more. As a result, force will be more, which may hurt you. But if you wear the seat belt, it will increase the time. How? When you wear the seat belt, then the time to be taken forward when you slide up to the window or when you apply the brakes, you move in a forward direction. So seat will seat belt will provide you a protection. It will give you a jack band. It will give you a shaken vibration back, so it will resist you from protecting your inertia of motion. So the time will be increasing, so rate of change of momentum is actually decreasing. That means change of momentum is decreasing. As a result, force will also decrease, so you will be less hurted or not hurted. These are the two exemplars I told you. Now let us do a question. Interesting question. This is a very interesting question I found out. The kinetic energy of a block of mass 3 kg is 150 joule. Find the momentum. We know P is equal to mv. This is a very logical question and very interesting question. You can try yourself, but I have provided the solution as it is not a class, it is a video. So you are provided the mass and the kinetic energy. You will think that P is equal to mass into velocity. So mass is given but velocity is not given. How we will find? It is not possible, but it is possible. So kinetic energy we know half into mv square. The formula of kinetic energy is half into mv square. It is given that Kinetic energy 150 joule. Joule is the unit of heat. Sorry, unit of energy. Heat is also energy, not wrong. Mass is 3 kg. So let the velocity and momentum of the block be V and P. Okay. We have just considered nothing is there. So we know that kinetic energy is equal to 0.5, or you can write half as it is written here. K is equal to half mv square. Same thing. And P is equal to mv. These are two equations given to prove it. Take out the answer. So using equation 1 we have put K is equal to half mv square. Now we will not do anything. Let us consider something else. We can write K is equal to, one step I am doing more to make you understand very easily. M square V square M square V square by 2m. 2m by half. So here 2 will get down and 1 into anything is that's simply that number. So 2m. So why V square is there? So why I have written M square? Why? Because here we have added one M. If we cut this M and it is M into M, so one M cut and one M cut. If we cut this to M, the same thing will be there. Half into mv square. Just an extra M I have taken. At last we'll understand why I have taken to prove it. So after this, m square v square means mv whole square. So by 2m. So k is equal to mv whole square by 2m. So k is equal to mv means p is equal to mv. So p square by 2m. And we are transposing it to mk this side. We are transposing this side. So p square is equal to 2mk. So p is equal to the square root of 2mk, right? So m is given 3, k is the kinetic energy that is given 150 and 2 into. So if you take out the square root of it, you can try it. The answer will be 30 kilogram into meter per second. Okay, why it is here given kilogram? That's why we have taken kilogram. Otherwise we could have taken gram, but here it is mentioned kilogram. That's why we have taken kilogram. So p is equal to momentum is the 30 kilogram into meter per second. Now this is the last slide. So deduce first law of motion from second law. Deducing means you have to take out, and anyhow means you have to prove. Actually deducing means prove. You can, by taking many means, you have to prove. So let us see how it has to be proved. Second law we know. From second law we have to take out first law. So second law we know you will not get it everywhere. It's very rare. Second law says that F is equal to ma. F is equal to ma. We proved it, right? How F is equal to ma. So according to the first law, if there is no external force, what is the first law? If there is no external force, then the body will be in rest or will continue its motion. So if F is equal to 0, F is equal to 0, there is no external force, then there is certain mass. Mass cannot be 0. For any body there is a certain mass. For a mass m, where m is not is equal to 0, m cannot be 0. So certainly if m is not 0, then a is equal to 0, because if this side is 0, then if left hand side it is 0, then right hand side it should be 0, and m into 0 means 0 only. So 0 is equal to 0 it will be. So a needs to be 0. A means what? Acceleration. Acceleration means change in velocity. So no acceleration means no change in velocity. So change in velocity no means v minus u is equal to 0. V is the final velocity, u is the initial velocity. So change in velocity 0. So v minus u is equal to 0. If you transpose this u this side, so v is equal to 0 plus u, so you get v is equal to u for any time t. For any time, how much time is taken we'll not see. For any time it will be v is equal to u. Final velocity is equal to initial velocity if there is no external force. That means the object will continue to be in rest, or it will continue its motion. That is the same thing. So the object moves with uniform velocity forever because v is equal to 0, no change in velocity with uniform velocity. And if u is 0, then v is also 0, which shows that the body is always at rest. That is okay. There it is shows that the body is always at rest. So if v is equal to 0, so v is equal to u, so u is equal to 0. So whatever will be the time, the object will move with uniform velocity or continuous state of rest. This is the deducing. So I hope you liked my video, and thank you for watching my video. Please subscribe my channel and like my video. Thank you.